In 10.2, we will be solving equations by using the multiplication property of equality. The multiplication property of equality states that you can multiply both sides of an equation by the same number and still keep the equation balanced. So it's similar to the addition property, we're just multiplying both sides. So in our example, we have 3 times x equals 42. Well, to cancel the 3, we multiply by the reciprocal 1/3. So remember, 3 times 1/3, that's like 3 over 1. So the 3's cancel, the 1's cancel, and you're left with x by itself. And then 1/3 times 42, so that's 42 over 1. So multiplying straight across gives you 42 over 3, which reduces to 14. Now note that the multiplication property of multiplication also permits dividing each side of an equation by the same number. So the more common way to solve this is if we had the problem 3x equals 42, my balance line is on the equal sign, then I would do the inverse operation. So 3 times x, the opposite of multiplying is dividing. So I would divide by 3. So 3 divided by 3 is 1, so that leaves me with 1x. And 42 divided by 3 is 14. Okay, so you can multiply by the reciprocal or you can divide. You'll get the same results. From this point forward, I will be dividing because that's the way you'll typically see it. In practice, it's usually easier to multiply on each side of the coefficient if the variable is a fraction, and divide on each side if it's an integer or decimal. So for example, if I have negative 3/4 x equals 12, because I have a fraction, it would be easier to multiply by the reciprocal. So I would multiply by negative 4/3. I would write my 12 over 1 so that my 3's cancel, my 4's cancel, and I'm left with x. However, if I had an integer or a decimal, like negative 5x equals negative 20, then I would divide by negative 5. Okay, so again, it works either way, but usually if there's a fraction, you'll multiply by the reciprocal. If there's an integer or a decimal, then you'll divide both sides. Okay, so now we'll start with looking at the examples in our textbook. Example 1 is on page 687. Check that 5 is the solution to 3x equals 15 and write the solution set. So to check that, I'll take my equation 3x equals 15, but I'll substitute 5 for x. So 3 times 5 equals 15. So that is correct. And then where it says write the solution set, we write some brackets with the solution inside, and that's the solution set. Okay, in MyLabs Plus, they'll have the brackets written for you, and you'll just type in the number. On page 688, we'll look at the examples and we will solve them. So again, we always start with my balance line, and then my problem states 6 times p equals 60, so the opposite of multiplying is to divide. So I'm going to divide both sides by 6. So 6 divided by 6 is 1p. 60 divided by 6 is 10. And I can check that by rewriting my equation. My original equation is 6p equals 60, so I'll rewrite it as 6 times 10 equals 60. That gives me a true statement, so that means that my solution of 10 was correct. Alright, on example B, we have 3 times r equals negative 12. So we'll divide both sides by 3. 3 divided by 3 is 1, so I have 1r equals negative 12 divided by 3 is negative 4. Then to check it, we'll have, instead of 3 times r, we'll have 3 times negative 4 equals negative 12. and I get the true statement negative 12 equals negative 12, which means my solution of negative 4 was correct. On example C, 15 times x equals 75, so we'll divide both sides by 15, and 75 divided by 15 is 5. So then 15 times 5 equals 75. 5 times 5 is 25. 5 plus 2 is 7. So my solution is x equals 5. And then again, they're asking us to write the solution set, so we should go back and put all of these in set notation. Okay, in example 3, we will continue solving equations. So A is 2 times m equals 15. So we'll divide both sides by 2. So m equals, now 15 divided by 2, I could change that to a mixed number or a fraction, but I really don't need to. Anytime if it doesn't reduce, you just keep it in fraction form, and an improper fraction is fine. So that A is just going to be m equals 15 divided by 2. And we'll write that in set notation. Okay, now if I wanted to check it, I would write 2 times 15 over 2 equals 15. Remember, 2 as a whole number can be written as 2 over 1. So if I cross reduce, then I have 1 times 15 is 15 over 1 equals 15, which is a true statement. Alright, example B. Negative 6 times x, so we'll divide by negative 6. And that gives me x equals negative 14 over 6, but I can reduce that. They're both even, so I can divide by 2. So 14 divided by 2 is 7, 6 divided by 2 is 3. So x equals negative 7/3, and write that in set notation. Okay, and then we can check that. Negative 6 over 1 times negative 7/3 equals 14. So if I cross reduced, 3 goes into 3 once, 3 goes into 6 2 times, so negative 2 times negative 7 is positive 14 over 1. Alright, and example C. 10 times z equals negative 45, so we'll divide both sides by 10. Z equals, and then 45 and 10 are both divisible by 5. So I'm just reducing the fraction 45 over 10. So that's going to be a negative 9. 10 divided by 5 is 2. Okay, and then to check it, I have 10 over 1 times negative 9 over 2 equals negative 45. Okay, so I can cross reduce. 2 goes into 2 once, 2 goes into 10 5 times. So 5 times negative 9 is negative 45. On example 4, we'll be solving this using the same steps, we just have some decimals. So negative 0.7 times m equals negative 5.04. So this is still multiplication, so I'll still do the opposite and divide. So divide by negative 0.7. Okay, so my 0.7 cancels, and I'm left with an m. And notice that I divided by the negative also, because a negative divided by negative gives me a positive m, and that's what I'm looking for. I'm looking for a positive m. Alright, and then negative 5.04 divided by 0.7. So that's going to be 7 into 50.4. So I move the decimal over one place on each so that I could have a whole number on the outside when I'm dividing. So 7 goes into 50 7 times, which is 49. 1, bring down the 4, 2. Negative divided by negative is positive, so m is equal to positive 7.2. Okay, I can check that by multiplying negative 0.7 times 7.2 equals negative 5.04. So I can check that by multiplying, so 7.2 times 0.7, 0.7. 7 times 2 is 14, 49, 50, 0. And then 2 numbers behind the decimal, so that would be 5.04. And then a negative times a positive is a negative. Example B, I have negative 63.75 equals 12.5k. So I can go ahead and divide by 12.5, or I can rewrite it so that my k is on the left side. So either way, whichever way you're more comfortable with, I am going to go ahead and switch it around so that it's 12.5k equals negative 63.75. Again, you don't have to do this. You could just start by dividing. So I'm going to divide both sides by 12.5. So 12.5 divided by 12.5 is 1. So I have 1k equals, and then when I'm dividing I want a whole number on the outside, so I'm going to move that over, so I'm dividing 125 into 637.5. Okay, so that will go in about 5 times. 5 times 5 is 25. 5 times 2 is 10, plus a 2 is 12. 5 times 1 is 5, plus the 1 you carried is 6. Okay, bring down the 5. 125 goes into 125 one time. Okay, so when we divide this, a negative divided by positive is negative 5.1. Okay, and then we can check that by multiplying 12.5 times negative 5.1 and see if it equals negative 63.75. So 12.5 times 5.1 there's 2 numbers behind the decimal, so 63.75, and positive times negative is negative. Okay, when we get problems like those on example 5, most people say, oh, I don't know what to do with fractions. Well, don't look at them as fractions, look at them as division. A is x divided by 5 equals 5. So if we're using opposite operation to cancel, then if I know that this is x divided by 5, then to solve it, I'm going to multiply by 5. Okay, so on the left side, I wrote 5 over 1, so I could see the fraction, so that the 5's cross cancel, and I'm left with x, and then 5 times 5 is 25. Alright, so then if I want to check it, I'll rewrite, instead of x divided by 5, I'll write 25 divided by 5, and 25 divided by 5 is 5. So example B will solve the same way. This is P divided by 4, so the opposite of dividing is multiplying by 4. So the 4's cross cancel, and I'm left with P equals negative 6 times 4. Negative times positive is a negative, and 6 times 4 is 24. Okay, and then to check it, I'll rewrite it. Instead of P divided by 4, I'll write negative 24 divided by 4. And 24 divided by 4 is 6. Negative divided by positive is negative. So my solution is correct. Alright, in example 6, this time we are introducing fractions. So to cancel the fractions, we're going to multiply by the reciprocal. So if I have negative 5/6, I'm going to multiply by negative 6 over 5. So that way I can cross-reduce my 6's and cross-reduce my 5's, so everything cancels except for the t. So if I multiply the left side by that, I have to multiply the right side as well, so negative 6/5, and we'll put negative 15 over 1 so that I have both of them are fractions. Cross-reduce, so the 5 and the 15 are both divisible by 5, so that's 1 and 3. And then we'll multiply straight across. So negative 3 times negative 6 is positive 18. 1 times 1 is 1. Okay, and then we want to go back and check. So that's going to be negative 5/6 times 18 over 1 equals negative 15. Okay, so multiplying, I can multiply straight across and then reduce, or I can cross-reduce. So 6 and 18, that's 1 and 3. Negative 5 times 3 is negative 15. 1 times 1 is 1, so 15 over 1 is still 15. Alright, example B, same concept. We're going to multiply by the reciprocal, so this is 3/5, so I'll multiply by 5/3. Put my 21 over 1 so that they're both fractions. So on the left side, my 3's cross cancel, my 5's cross cancel, and I'm left with k. On the right side, I can cross reduce. 3 and 21 are both divisible by 3, so it's going to be 1 and 7. And then multiplying straight across, negative 7 times 5 is negative 35 over 1. Okay, then we'll check it. It's 3/5 times negative 35 over 1 equals negative 21. We can cross-reduce, so 5 goes into 5 once, and 5 into 35 7 times, so 3 times negative 7 is negative 21. Okay, in previous sections we've said that if I see an x by itself, that's understood to be 1x. Or if I see a negative x, that's understood to be a negative 1 times x. So a can be rewritten as negative 1 times m equals 2. B can be rewritten as negative 1 times p equals negative 7. So anytime you have a negative in front of the variable, treat that as a negative 1 times the variable. So then to get m by itself, I'll divide by negative 1. So negative 1 divided by negative 1 is a positive 1, so I just have 1m equals 2 divided by negative 1 is negative 2. Okay, checking our work. Negative m, which is negative 2, equals 2. So negative negative 2, the opposite of negative 2, is a positive 2. Same thing for b. I have a negative 1 times p, so I'll divide by negative 1. So p is equal to negative 7 divided by negative 1. A negative divided by a negative is a positive 7. And then we can check that answer by negative 7 equals negative 7. So positive 7 was the correct solution. Okay, and our final example for this section, we'll have to simplify before we can solve. So on A, we have 7m minus 5m equals negative 12. So I can combine my like terms. 7m minus 5m is equal to 2m equals negative 12. And 2 times m, the opposite would be to divide by 2. So 2 divided by 2 is 1. So I have 1m equals negative 12 divided by 2 is negative 6. Okay, when we check that, we need to plug in a negative 6 everywhere we see an m. So it's going to be 7 times negative 6 minus 5 times negative 6 equals negative 12. 7 times negative 6 is negative 42. 5 times negative 6 is negative 30. Okay, recall that a negative and a minus together makes a plus sign. So I have negative 42 plus 30. Okay, so if I have 30 and I spend 42, that means I had to borrow or put on credits or owe money somehow. So I'm going to subtract to find out how much money I owe. Or you can look at it as if I had 30 circles across the top, 42 across the bottom, I would cancel 30 of them, and I would be left with 12 at the bottom. So that's negative 12 equals negative 12. Okay, and our last example for this section. 4r minus 9r equals 20. So again, we can combine like terms. So 4r minus 9r. 4 is positive. Subtracting 9 is the same thing as minus 9. So again, I have 4 pairs to cancel. That leaves me with negative 5r equals 20. So negative 5 times r, the opposite would be to divide by negative 5. So I get r equals negative 4. Okay, if I go back and check, 4 times negative 4 minus 9 times negative 4 equals 20. 4 times negative 4 is negative 16. 9 times negative 4 is negative 36. Okay, minus a negative, it's going to be a plus. So now I have negative 16 and positive 36, so 16 pairs will cancel and I'll be left with 20 at the top.